Example 6. Integrating a discontinuous function. So in the previous examples, we've always looked at continuous functions so the area was not split up. In this example, we're going to look at what happens to a function if it's discontinuous at a point. So we want to determine the integral from -1 to 2 of the absolute value of x divided by x dx. The first thing I recommend, if you don't already know what the graph looks like, is to take a second and look at the graph. So take a second now and graph this on your graphing calculator. So we can see right here at x equals 0, there's a jump in the graph. So this graph is not continuous. So what we have to do then is we need to split up the integral so it becomes two integrals. So again, an integral is the area between the x-axis and the curve. So what we're trying to find then is this area and this area. Now I want to make the note that if the area is underneath the x-axis, then it's negative. Again, if the area is underneath the x-axis, it is negative. I know we can't have negative area. However, with an integral, you can get a negative answer. So we have the integral from -1 to 2 of the absolute value of x divided by x dx. And we need to split that up so the integral is continuous. So from -1 to 0, it's continuous. And then from 0 to 2, it's continuous. So this is a property of integrals that we can actually split them up as long as this point matches this point. So as long as they can connect back together. So the area underneath this section from -1 to 1, this section right here, is going to be 1. And this area right here is going to be 2. So this becomes -1 plus 2. So the answer is 1. That's it. Whenever you have a discontinuous graph, you split up the integrals so you find the integrals of the continuous portions. Now I want you to try this one. The integral from -2 to 4 of 2 times the absolute value of x divided by x dx. So again, I recommend graphing this on your calculator and then looking at it to determine where it's discontinuous. So take a second now, pause the video, and solve this out. Okay, so if you graph it on your calculator, it should look something like this. Now we can see yet again that it's discontinuous right here at x equals 0. So this is the point of discontinuity. So when we write our integral, we're going to write the integral from -2 to 4 of 2 absolute value of x divided by x dx is equal to the integral from -2 to 0 of 2 absolute value of x divided by x plus the integral from 0 to 4 of 2 absolute value of x divided by x dx. So remember, the integral is the area between the x-axis and the curve. So the area that I'm looking for here is going to be 4, and the area in here is 8. So you get that this is equal to -4, this is equal to 8, so your answer is going to be 4.